Welcome to the last in this podcast series focusing on demand-driven MRP. I'm Ken Titmus, and today we will be mainly focusing on demand-driven sales and operations planning and completing the series with a summary of the podcasts. In the last podcast, we completed the fifth and the last component of DDMRP, namely visible and collaborative execution. We also spoke about the 6 DDMRP buffer criteria and how reorder point systems and safety stock don't provide the same benefits. Before we get into demand-driven sales and operations planning, I just want to spend a short time on DDMRP's impact on scheduling compared to traditional master production scheduling and shop floor scheduling. With conventional planning, we drive the traditional MRP system from a master production schedule, which represents what the company plans to produce in specific configurations, quantities, and due dates out to the cumulative lead time. This plan, possibly going out 6 months or more, is built based on inaccurate forecasts. So what are the assumptions we use when planning our organizations? Number 1, demand signals are known and accurate. Number 2, lead times for order release, receipt, and synchronization are realistic. And number 3, materials and capacity are available on the dates required. How realistic the schedules are will be determined by the relative validity of these assumptions. The less realistic the schedules become, the more likely they are to be disrupted. So let's see how realistic these assumptions are in the conventional planning approach. Let's looking at assumption number 1. Demand signals are known and accurate. With conventional MPS MRP planning, when we tie order release directly to forecasts, this means that actual demand will vary from demand used for planning. The longer the planning horizon, the larger the variance will be between planned and actual. With MRP's inherent trait of nervousness, means demand signals change at each and every MRP run, creating a great deal of adjustments. When using a DDMRP system, the use of qualified demand means demand signals are much more relevant, accurate, and timely. With assumption 2, lead times for order release, receipt, and synchronization are realistic. Using traditional MPS MRP planning with no decoupling, delays frequently accumulate, affecting when orders can be released with full allocations. We find safety stock is generally not positioned at the intermediate levels in the bill of materials to provide even partial supply variability dampening. The traditional MRP then nets inventory positions to 0, leaving no margin for error. This means the schedules are much more complex and fragile. Also, with no execution ability built in, there is no way to see how potential delays will affect the schedules. There will be little or no visibility of a potential problem until it is encountered. And without decoupling, synchronization and flow will quickly break down. In DDMRP, the use of decoupling points creates a shorter, independent, planned and managed horizons, with less variability being passed through the system. This results in synchronization dates that are more realistic and less important due to the cushioning effect of the buffers. These buffers being correctly sized through the use of the decoupled lead time. Looking at assumption 3, materials and capacity are available on the dates required. When synchronization breaks down, materials and capacity are frequently not available as planned. Materials arrive late or are diverted to cover other shortages elsewhere. Capacity is frequently not available due to slides in the schedules. With DDMRP, buffers represent a point of stored materials and capacity. The buffers always plan to have material available. DDMRP's execution facility brings degrees of visibility to open orders that must be expedited to maintain stock integrity and meet synchronization needs. One of the key differences between a traditional MPS MRP system is the MPS gives us a statement of what we can and will build, whereas a DDM&OP provides a statement of what we can and will sell, a fundamental shift in a company's capability. When it comes to DDM&OP and shop floor scheduling, works orders or finished products, intermediate subassemblies and manufactured components are launched based on buffer net flow status. This creates a much clearer schedule based on actual priority. In addition, DDM&OP buffers can be seen as a simple finite capacity scheduling system. If we take the green zone in the buffer, it indicates the average order frequency and quantity. If we know the quantity and the time required to produce this quantity on any work center in the plant, we can calculate the average time to produce this average batch size. Moving on to the main subject for today, which is demand-driven sales and operations planning, DDS&OP for short. The Demand-Driven Institute defines the DDS&OP process as follows. DDS&OP is a bidirectional tactical reconciliation hub in a demand-driven adaptive enterprise model between the strategic and operational relevant ranges of decision-making. The DDS&OP sets key parameters of a demand-driven operating model based on the output of the adaptive S&OP process. DDS&OP also projects the demand-driven operating model performance based on the strategic information and requirements and various demand-driven operating model parameter settings. Additionally, DDS&OP uses variance analysis based on past demand-driven operating model performance against critical metrics of reliability, stability, and velocity to adapt the key parameters of the demand-driven operating model and/or recommended strategic changes to the business. The DDS&OP then has two basic functions. One, to create the master settings for your demand-driven operating model and look at variance analysis to see how the operating model can be improved. And secondly, to project the operating model into the future based on your consensus demand plan to determine areas of, for example, capacity, space, and investment that need to be addressed in the future due to potential increases or decreases in business. Let us start with looking at the analytics. Once the design is operational, how do we ensure that the flow of relevant information and materials is occurring for the best possible return on investment? For this, we need to ask the following four questions. 1. Are the right signals being conveyed without distortion in a timely fashion? Are the right materials available when needed, or is the inventory in excess? 3. Is the operating model performing as designed? And 4. How can we make it better? In the DDI Demand-Driven Planner course at this point, we look at some typical reports that determine the answers to the previous four questions. A little difficult to do in this podcast. We look to see if planners are placing orders correctly in a timely fashion. How fast is the model working? And are we getting good flow through the business? We look at buffer integrity and determine if the right buffer profiles are being used to ensure availability. Lastly, we analyze the SKUs that continually either have too much or too little in the buffer and determine how this can be improved. In other words, we set up a continuous improvement program. Improvement strategies should be in place to ensure reduction of investment in the buffers, but maintaining or improving customer service levels. These revolve around three issues: lead time reduction, MOQ reductions, and reductions in variability. Let's now look at the second function of DDS&OP, that of projecting the demand-driven operating model into the future based on the consensus demand plan. In the Demand-Driven Planner course, we take 4 SKUs, look at the current ADU and the future ADU in 6 months, and project the changes in the buffers into the future. This enables us to compare such things as potential inventory investment increases in the buffer, future warehouse space requirements, or maybe capacity requirements in the plant, or whatever you deem critical in your business. This gives us a heads up to the future problems and gives us time to address them. This now brings us to the end of the material in the podcast series as found in the Demand Driven Institute Demand Driven Planner course. To summarize, remember there are 5 components of DDM&OP: strategic inventory positioning, buffer sizing and buffer profiles. Thirdly, dynamic adjustment, and then demand-driven planning. The 5th component being visible and collaborative execution. We have discovered that by applying some innovation to the best aspects of MRP, DRP, Lean, Six Sigma, and Theory of Constraints, we have adopted or developed a multi-echelon materials planning and execution solution that can be used anywhere in the supply chain, from raw material extraction through to retail. The benefits the DDM&OP adopters are enjoying include improved customer service, lead time compression, right-sized inventories, together with lower supply chain costs. But the key benefit is an easy to understand and operate intuitive system. Finally, the key fundamental principle of DDM&OP is flow. The main fundamental planning changes are using accurate sales orders rather than inaccurate forecasts and decoupling the supply chain with buffers. The key operational equation elements are lead time, buffer status, and minimum order quantities. This we find results in higher service levels, lower inventories, and fewer expedites without trade-offs. The ultimate effect is a greater return on capital employed, which has to be a major performance metric for any business. Find out more by reading the books written by Carol Patak and Ched Smith, and attend a 2-day demand-driven planner course, which are run publicly around the world. They can also be run in-house at your company with your team prior to starting a DDM&OP implementation. For those of you that are unable to find a public course close to you, the DDI does run an online DDP webinar series. Find out more on the DDI website at www.demanddriveninstitute.com. I'm Ken Titmus, and if you have any questions or queries, you can contact me on ktitmus@mweb.co.za. That's KTITMUSS at mweb.co.za. Good luck on your DDM&OP journey, and if we can help, contact us.